Isaac, are you in the wrong spot? She was wondering if she was in the wrong place.
I was like, which one's
Is it me? Oh no. Jacob's not here. There's Jacob. Morning. I think we're just missing Tori and Jackie. Let's see. Mark them. How is everybody this morning? Bright and cheery. Any questions or problems before we get started? Anything we should look at? Guys got it all? Everything's under control? Good. Any questions from the people at home? We've got an opportunity here. Thanks, Rich. Try to get everybody in. Our book has a lot of example code, I know, and we're going to look at that big example that they do in chapter 21 together. So if some of you have gone through it already, can help us with it, help everybody get through it. But we want to understand why we're doing things the way we are. And you'll see between chapter 21 and 22 all these different, like I've mentioned, C# classes, .NET classes that let you access databases, and you have so many different ways of doing it. It can be a little bit overwhelming. And the older style way that we're going to be looking at today, where we manually issue the SQL code, is, I guess that would be the original way of doing things. And then data grids and data sources and all those kinds of things are much newer. So they're much more automatic, but they take away part of your control. So just like everything else, anytime we automate, we lose some of the finer details of control And sometimes we need that. One reason that we might need that is if we're doing component-based development. And we've done a lot of that already, creating our class libraries. Those were component classes that we could use in other applications. But we can also talk about component-based development from like a hardware, software installation sort of aspect. That's what we're really thinking about, because we're the software developers. So the more intense software we create, the more resources we use, the more important it seems like we are. And some programmers actually are that way, where they're like, I was able to use every bit of RAM in that server and just bring it to its knees with my awesome code. And sometimes we have to do things like that, depending on the task that's been assigned to us. We might have to create something that really uses a lot of resources. We want to separate those resources off so that we can control them. So we want to have different layers of applications. First of all, we have the presentation layer. In the middle, we have the business layer. And then in the back end, we have the data layer. So that's one picture of looking at this. We can look at a bunch of different ways. Another way is kind of this top-down approach, where we're sitting here as a user. We see the presentation layer, that front-end beautiful screen that was created with HTML and CSS and JavaScript or C# or whatever it is we're using for that presentation layer. And that presentation layer is associated with business layer code, all of our classes that define, in this example, our cars and our inventory and customers. That's our business layer. Then we're going to be connecting to the database to get the data that actually is behind those business layer objects from our database. So that kind of top-down approach shows you, again, we have these different layers and they're all communicating with each other and working together. So that equates to our hardware, because I'm running all of my presentation stuff on this client PC. We have to be concerned about that, right? If all of a sudden our company decides, like schools have, that we're not going to buy PCs, we're just going to buy everything Chromebooks, now we have to redo a lot of our intention here with this client front end. So we have our front end, our client stuff, depending on our hardware. The software we use is usually dynamic, and we try to make things be very visibly appealing, all that important stuff. Then in the middle, we have our application servers, our business servers back in the back end. I found this picture of some server racks because that's what I would see commonly in a business's server room, a bunch of different servers that are assigned different functionality. Then, when Mary's program has to go into production that uses every bit of RAM known to man, we can just slide some more servers there in that rack, right? And now we can handle it because our business needed that application to work. It's so important. It does really important things for us. So we can add more hardware, more resources to that layer that needs it. Does that make sense? Because if we have everything all in one program, all one console-based program, we can't do anything to allocate resources to different pieces, different parts of it, right? We're stuck just throwing resources at the whole thing. Our servers died, we need more RAM. Our servers died, we need more RAM. When we have everything separated, we can control what's going on individual pieces of hardware. In my very back end then, I'm going to have my database server. Ours is an AWS server, an Amazon Web Server. So OTC is charged per month for that server. If we start using a bunch of resources, we've got a bunch more people on that server, our per month charges would go up. That would be okay because we would need those resources. But that way we just have those resources allocated just to that back end where we need them at the database server. So that's why we have these component-based applications that are so important to us. We can separate everything out. So I can have all of the calls to the database, all the SQL code and everything, basically running on my database server. If I have an increase in activity there, I just add more resources to those machines. So that's why we want to do this component-based layering sort of software. And if you can think about that, it helps it make sense. We hear a lot in our field about front-end and back-end developers. And as you get closer to graduating, people will be asking you that a lot. Or do you prefer the front end or the back end? Here's a cute picture. I didn't want to steal it. So you can kind of see what's going on there. We consider a front-end developer as someone who is adept with the HTML, CSS, SA type code, and oftentimes we'll consider somebody that's a front-end full stack developer. They're full stack. They also, up here on the top, maybe are pretty proficient with Photoshop and some other tools like that that are helpful in creating websites and doing that kind of design. So that's our front-end people. And then our back-end, you can see we've got the big iceberg down under here because the back-end is a lot bigger and a lot more resources going on there than what we see from the surface. So a user may not realize there's all this activity going on this back end. So our back end would be our database stuff, PHP, C#, all of the things that we're working on can run on the back end on that server side. So that's where people start getting their feeling for what they prefer. Some people would rather spend the day, working with pictures and designing a layout and things like that. Other people would rather spend their day designing databases and getting everything allocated and things like that. So just a difference in functionality and job description. And it's always interesting to see how people really do prefer one area or the other, but it doesn't mean you can't veer off. If you're a back-end developer, you sure can jump in there and help the front-end people and do whatever you want. In some companies, you're just going to be full stack. You're just going to have to do it all because it's a smaller place. Those are the fun companies, where you really get a chance to kind of do everything. So we're getting like doctors, a little bit more specialized than just everybody doing everything all at once. So let's create our application. I'm going to open Visual Studio. And we've already got our database tables created. So we created, I'll open SQL Server also, get everything going here. Being slow today. Make sure I'm connecting to my 151 server. And remember last time on our database, we created a database diagram. So we can pull that up, double click it to open it, I guess. That is the special database diagram crash. I think I mentioned last time SQL Server Management Studio was handling database diagrams less and less effectively. I don't know if yours crashed, but mine did. Try that again. See if I get the same results. Now it's trying to open, I think. Nope. It's just gonna crash. I'll open it anyways. Just in case I need to do something with it, but it's not gonna let me look at that. Is anybody being able to look at their diagram? No, not letting you. Crashing. Well, doing having to do it twice, I guess it's going to do the same thing over again. You know, they say you can. Okay, take over. Let me stop share just for a second. And you guys share your diagram super fast. Just for a moment. I think my coffee cup is leaking. Thanks, guys. Working just because you're at home, show off. All right, so remember, we just had our three little tables. We have our customer table and our inventory table, which is our cars. And then in between, we have our orders table that's making that connection to customers that have bought cars or ordered cars. So we have our relationship set up, and we should have some data in there. So we should be ready to go. Thank you, you guys. Nice that your database works. I'm going to share mine again. I don't really need to. So can we do that in Visual Studio? I bet we can. Let's create a new project. And for our first project, we're going to create a class library. And then we'll add a tester kind of project out to it. So let's do our class library first. And they have a name for us. I think to avoid issues and problems. Well, let me make sure. I need to, and I think I have .NET Standard. Yeah, let's do a class library.NET framework. Thank you. Just gonna get that standard one again where I would have been, why is nothing working? So last time we saw that factory model, and if you look in your chapter more to the other examples that we haven't looked at, you'll see that we can do our calls individually to our different database management systems. The factory model just kind of makes it to where we don't have to. But in this application, we will be using the SQL Server classes specifically. So if we wanted to change it to use access, we would have to change all those class names from SQL to OLE. So that factory that we were looking at last time is pretty high level. And we would only use something like that in a company that probably sold software, because we would sell our application on many different platforms. So we would be able to support Access as a platform for small companies and SQL Server as a platform for larger companies. So that factory thing is pretty advanced, you know, not necessarily something that a smaller company would use. So they want to name this thing Auto Lot DAL. And Tori's here. I'm going to name it that, like I said, just so I don't get things all mixed up, because we are going to have a lot of different pieces. Since I'm going from theirs and not one that we've created ourselves, we'll take a look at it. So for our first class here, we want this to be our inventory DAL class. So let's rename it. And we've already got our classes public, which they wanted. They'd like us to create a new folder because we're going to separate out our components again into those different layers. So make sure you're on your project, and on your project you can create a new folder. And of course there's lots of different ways you could do that. I'll just right click and do add new folder. And we want this folder to be named data operations And you'll see different names. A lot of times people will call it data access, or maybe just DAL for data access layer. So that's really what this folder is going to be. It's going to be all of the classes that we create to access our database. So let's move our class in there. Or I'm going to do it the way they said, because I don't want to mess up my solution or my namespace name. Let me delete this one, the predefined class. And let's create a new class within our new folder, because remember how that impacts our solution name. So within our new folder, let's add a class. And we want it to be inventory DAL. Sorry about that, I just don't want to get it messed up. And let's make our class public. And this would be a common thing for us to do in a company for setting up a new database. We've gone through all of the design and we've decided what our tables are going to look like, what our relationships are. We're going to create that database in some sort of test server, and then we're going to create a class to kind of be the connection to that new database or new set of database tables. For this one, we're going to be using our SQL Server provider. So let's get our using statements in there. System.data is the library that we want to access all of the ADO.NET database classes. And then since we're going to be using the SQL Server one specifically, we want system.data.SQL client. And you could just do a quick Google search if you were using a different kind of database to find out what that library is. You know, they want us to add some constructors. So we'll do that first, since that's the order that they're going to do things. So our first constructor is going to be public. And we're going to say that we want a parameter that's going to be that connection string. Remember, our connection string is that code that says, here's where my server is, this is my server's URL or file name or whatever, and this is how you connect to it. So we want that connection string to be passed into our class. They've used the shortcut because they only have one line of code here. And they're actually going to create this variable within our class. I skipped that, we'll get it, called underscore connection string. And we're going to set that equal to the connection string that was passed to us. And I know in our textbook, they always use the underscore for private class variables. And I've done a lot of research on that, and it's not really a convention. But again, you know, as long as the people that you're working with are okay with it, you could do it that way. But they also have a special thing about this string. They said that it's a private read only. So that means we're not going to have any public properties associated with that connection string. It doesn't mean that we can't change it, because we'll be able to change its value. It just means that we don't have a hidden property associated with it. Okay, so that's our first constructor. I'm going to put a comment there. Our primary constructor that accepts a connection string. And we're going to go ahead and set up another constructor so that it has like a default connection string, so that we don't have to worry too much about actually using that when we call our class, but we can if we want to. So this constructor, our parameter is going to be a little bit different. kind of just giving it a default, this default. So we're saying for the parameter for this constructor, pass in this value if none is supplied. And the value we're going to give it is our connection string. So let's go off to Canvas and find that. I want the one that's in the document. Because it should have the whole string. I don't know if I have it set up in a way that's easy to copy. Not really. So I'm just going to move this off to the side so I can get it in here. For our data source, we want our launch server name. I'm copying it from the worst possible place, obviously. Why it's doing that, I'm sure someone did. Try to get it to where you can see most of it. So I started out with my data source. And then at the end, last time we took off the port number, the comma 1433, and we put a semicolon at the name. I got it, it just went crazy and added all those spaces back in. I'm going to see if it'll work without messing with it. I'll copy it from someplace else. Now, the other things that we need to specify are our initial catalog and our security information. So all this needs to go within the same string. So my initial catalog is going to be your database name. Helping me. And then our user ID. Whoops, and I've got to get these parameters just right because these are being used. I'm getting a lot of help here from IntelliSense on this never-ending string. Seems as though something has been turned back on my machine. So I'm trying to do this as is type thing. There we go. I've got an extra double quote. See how that works. Made it much better. Now, according to them, we should just be able to have our open and closing curly brace. So what we're doing here is like, if we call to create a new instance of our class and we go to execute a constructor, if we pass in a parameter, then this constructor will get called, our inventory DAL constructor that expects a string parameter, and will update our connection string within our class. But if they call to create a new instance of this class or to use it without a parameter, then this constructor will get used that already supplies the default value for the connection string. Makes sense. It's a little bit ugly, but that makes a lot of flexibility for us because this way, if we're testing our software and we want to pass in a connection string that specifies a different server, like our test server or something, we can do that easily because we have that set up. Now, I don't think mine's okay, but I'm going to quit messing with it because I want to go on and get some of this other stuff done, and then we'll come back to it when we're ready to test it, because it'll be easy enough for me to copy it from another piece of code if this one, I don't know if it's going to care about all these spaces. I think it will. So the next thing we're going to do is open and close our connection. Whenever we are working with a database server, we've seen that we have to connect to the server, establish that connection so that we're having an open line of communication. The next thing that we want to add then is a SQL connection object. I'm going to do it the way they do it and the way we do it. SQL connection. So we are using, since we're using the SQL data class, the SQL connection object should be known. We're going to name this one again with the underscore SQL connection. And we're going to give it an initial value of null so that we know we're not connected. Now let's create our open method, build our class a little bit different, because this isn't really like a data class like we're used to building. This is more of a utility class that's going to do things for us. So we do build it a little bit differently. So for our connection, we're going to create a method and we're going to make it private. We're only going to be using this connection method from within our class. We're going to update our SQL connection object. Oops. And we're going to pass in by name our connection string. So now we've got our connection string established in that connection object. And now we can use that SQL connection object to open our connection. That looks good, except that we don't have any sort of try-catch logic, and I've got some sort of curly brace issue. I'm missing one. That looks better. And so everything looks good, but we don't have any sort of try-catch logic. And in our textbook, they say, you would include try-catch logic. Well, let's go ahead and do it. We'll just say try get everything lined up a little bit, and then catch. Now, the reason that our textbook has left this out is because we're within this class. What do we want to do if we catch an error? In general, we wouldn't want to like have something display on the console. You know, we don't want to have user interaction in this code. This code is supposed to be running on the back end on our database server. We don't have any way to really get a message to a user. So what we could do is like log an error. So we always do that console.write. We can do an error. Let's check. I want to do it correctly. I'm going to open a search and C# error log. Now they give us all sorts of ideas, and they're going to say, oh, you should create a logger class and you should have all of these extra things going on to log errors. That's true. We should do that, but we're not going to be able to build that kind of established application at this point. So all I want to do is know how to log an error. They've got this fancy logger class built. That's no good. Somebody find something. It's like console.write and C# for an error. Is that a good thing to search? Not really. but it worked. So whenever we're working with our different console classes, we could actually send output to an error location. So instead of just writing something out to the console, we could log it to an error log so that we could look at some things. So here's one where they've set the error as a certain file, and then they're writing output to it. So we just want you to realize that, you know, we would need to do something like that to handle things perfectly, to be the ideal solution. We'll go ahead and just write something out to the console because we know that we wouldn't do this forever, but we could do it temporarily while we're in development. Open connection error. And if I go ahead and catch that exception object as exe, then I could write out its message. Now, again, I can't emphasize to you how much in a real world we would not be interacting with the console from a data access layer class. But in our development effort, we will do so that we can make sure we could catch any sort of errors as we're developing. Let's put some comments here. This method opens our connection. Besides needing to open a connection, I need to be able to close a connection. So let's create that method. Close connection. And in this one, we're going to actually check to see if our connection is open. So SQL connection. And we're going to use this state property of our connection object. That question mark allows us to query that state of our connection object, the state property, and we're going to see if that connection state is closed. If it is, or not equal, I'm sorry, if it is not closed, then it's open. That's an interesting way to do it, huh? So we'll close it. Again, we would want a try catch here because we'd still want to know if we get an error. We're not able to successfully close our connection. Okay, so some basic code. Just like the other day when we were creating our connection to our access database, we want to get the connection established and then we can work from there. So we've got these two methods going. Now, after we've got our connection established, we're going to get some data. So let's create our class to hold our data. And in our access application, we called our class inventory, which is common to call the class the same thing as the table name, right? Because that makes the connection between your database and your code. Well, our textbook is using a different name, which is also perfectly allowed. So it just gives you something to think about. I'm going to create another new folder first because our car class is going to be one of our business objects or business models. So let's name this models. And in our models folder, we want to create our car class. I can just say car. Our car class We're going to make it public. And we're going to do a pretty much a shortcut one here, just with our properties. We want car ID, and we're going to use a getter and a setter. This class code that's being created for our database connection with all of the data access logic is going to be something that becomes really important to our company. And all of the software developers that work for our company will be using these classes and these tables. We'll have our getters and our setters. And finally, pet name. Ooh, Rich has a good idea. Rich says to log to another database table named odd.errorlog, but I can't do that if I'm not connected yet. So it's one of those, which came first, the chicken or the egg type situations. Now our car class, let's do some documentation. This class defines an inventory object. And of course, we might need more documentation, but this one's pretty short and sweet. I don't think we need to explain a lot. So we saw from when we worked with our access system that one of the first things we needed to do was be able to select data from our table so that we can see what we've got out there, make sure that our application can actually do that. So we're going to create a get all inventory method that's going to allow us to call it, and it's going to return a list of all of the cars that it finds in our table. So we should be making this thing, where do we want it? We're going to put this in our car class. That just doesn't seem right. It's got to go into our inventory DAL.class because this is data access. We're going to be accessing our database, so I don't want it to be in our car class. Our car class might need to call it, but the actual method itself should be in our data access class. Now, because we're going to be using code from this other folder, we need to add a using statement for that folder. For them to kind of get to each other. So it should be able to see our car class now because we put that using statement in. Okay, so now that I've got that using statement, I'm going to go after my connection or closing my connection and create this new method. It is going to return a list of car objects. And our method is going to be named get all inventory. So the first thing we want to do in our get all inventory method is open our connection. Assuming our connection opens properly, let's allocate our list. We have a list of car objects. We're going to call it inventory. So that should set up our list of car objects. And then we want to set up our SQL command. So this is an interesting choice that they've decided to set up the SQL statement within the car class. That's just a decision. Or I'm sorry, within our data access class. So we're setting up our SQL. We're going to select everything from our inventory table. Now we're going to use a using clause. And we haven't used these a lot. We haven't used a lot of usings. We've used a lot of usings when we're bringing in libraries, but not within the code. So let's get this put in, and then we can review what it does. We're saying using the SQL command object named command that is actually new. I want you to process the SQL code using the SQL connection. Oops, no semicolon. Now, the using command says, whenever you are looking at this resource, I want this resource to be allocated to run all of the block of code within this using command. When that block gets done, when we hit the end of the command, all of these resources are going to be released. So tables and SQL readers and all those kinds of things that we might open within our using command will all be closed for us automatically, and we don't have to do anything to open or close them. So the using command just allows us to set up resources that are temporary, and it'll go ahead and take care of eliminating those resources from memory after we're done. So what we want to do is tell the system where our command is, or what kind of command we're using. So we're going to be looking at doing an execute reader, executing an SQL command kind of manually from our code. So the first thing we're doing is saying, hey, command object, the type of command that you're going to be running is text. Because we have our SQL statement in a string. So that's standard. We're just going to be running it from text. We saw too that we can allocate a data reader to hold all of the data that gets returned from our SQL command. So we're going to do that. And we're going to execute the SQL code associated with that reader. And when it's done, we want its command behavior to be to close the connection. So our code looks a lot different than it did when we were working with our Access database. But what's cool is we could actually use the same code back and forth for either one. It's just the names of these classes that are a little different between our different database management systems. But if you notice, if we were to open up that project we did last week, you would see that we created a command object, and then we did the command to execute that command object to load up our data reader. But our code just looked a little different because we were just using different methods and using some different capabilities. So we do have a lot of ways of handling things. Okay, so we've said, hey, fill up a data reader for me. And that should be the end of our using clause, I do believe. Nope, I'm still in it. Now our data reader should be full. It should have a whole bunch of inventory objects in it. So let's process those. While we can read one of those objects, we want to handle it. This is some interesting syntax. So for our new car, we're going to set our car ID equal to an integer that we're going to get from the data reader by finding the column named car ID. Next, still within the curly braces of setting up the parameterization for the add of our inventory object, we're going to set our color equal to, and this one of course is a string from our data reader, and we want to read the color. Column. Oops, need a comma there. Next, our make. Oops. Make. So you can see how developers were like, God, this is so hard to have to keep putting the same stuff. Why can't the data reader just be connected to my class and understand which column is associated with which variable, because I have them named the same and all that kind of stuff. So that's why we've ended up with all of these automated classes that do take care of that stuff for us. And then we end up still having to use kind of the old school ones because we want to be able to separate out our code. Okay, finally, done with that parameter list of items to load up that inventory. So what did we do there? We said that I have a list named inventory, a list of cars. I'm going to create an SQL statement to get all of the cars from my inventory table. I'm going to use a using command to execute that SQL command object. I'm going to tell the command object to find its SQL code in a text field, and then I'm going to tell it to execute itself, loading up this data reader. I'm going to look at each item in the data reader, and for each item, I'm going to add it to my list of cars. In my list of cars, there are going to be actual car objects, and each of those car objects are going to know about their different data elements because we've associated them with the data elements that we find in the data reader. So that's what we've done in this method is we've gone through and we've connected everything and we've gotten all of the cars out of our inventory table. Now, after our while statement, they issue the command to close the data reader. But from my understanding, the using clause should really take care of that for us. But I'm not going to jeopardize things and argue. Now, finally, when we're all done, we're ready to return that inventory. Find my right spot here. So we're going to return that list of cars to our caller. So that's going to be a method that's going to be used often because all of our different application pieces that need to list the cars that we have on the lot are going to call this thing, right? So we're going to be having a method here that gets used a lot. Let's try it. I'm going to skip ahead a little bit and create our console-based application to call this thing because I'm going to do some testing before we've gotten 2 or 3 more hours of coding in on this thing. So there's several different ways I could do this. I could create a new folder with my console project in it, but since I said that this was a class library, I could end up having to change a lot of things. So instead, I'm just going to add a new project to our solution. Add a new console application, blah, blah, blah. Yeah, we'll do it that way. So add a new project, and I want it to be a console app.NET framework. And we'll name it AutoLot Client. So it's our client, our tester, however we want to look at it. Now, in our client, we're going to need to be able to access stuff from our other project. So AutoLot, DAL, dot we got to add our reference too. That's why it's being mad at me. So in our client project, on your references, we want to add a reference to our other project. So it should just be right there in our projects. And then my errors should go away there for my using if I type things properly. And I really want this client to be my startup project. So I'll go ahead and make that change here also to set it as our startup project. So we've created our class, our data access layer class is a class that actually does get instantiated with an instance. We could also make it like a static class where we just called our methods directly to do things. So you could do it a lot of different ways. So we'll call that instance DAL, short for data access layer. And this worked good for us because we're able to set up those constructors and allow people to pass in the connection string or not. So that was kind of a neat thing for us to do by setting it as something that's an instance class. So that worked out. So we want to create an instance of our class. And then right off the bat, let's set up a list using our getAllInventory method that we've created. And then we'll print those out. Console.WriteLine. They have all sorts of stars. All cars. After that big heading, they want to output a detail heading, car ID, then a tab, then the make, and a tab, and the color, and a tab, and the pet name. Now that we're all set up, let's go into a for each loop to process that list. So for each, and we're using that var data type again, for each item in our list of cars, let's write it out. We're going to start out with our parameterized list, itm.carid, and then a tab. And then we want our make and a tab, and then our color. And finally, our pet name. Close that. That should write them all out. So let's try it. There's more for our console app that we'll be adding, but that's a good amount for us to try to see if we got this thing connecting to the database, doing all those kinds of things. So what kind of terrible, terrible mess we've got. Took it a minute. So first of all, the server was not found or was not accessible. So that's coming from our connection class where we did our try catch. So since we have our console app, it's okay. You know, we're seeing that error message. So did anybody connect successfully? Let's see yours. I'm stopping. Let's see your connection string. We need to see your data access layer class. My connection string is just a miserable mess. That's what we want. Showing us your password. Beautiful. Now, yours is running, huh? How's everybody else? What are you guys getting? I'm getting an error. I'm getting an error when I try to run the SQL command. Can you go to the using clause in our list, get all inventory method? So mine, I think, is because I have my password wrong. How's everybody else doing? I'm going to take this back. Thank you, thank you. Yeah, I forgot, and I was doing a password like you guys, and I had to change it to the weird one that I have. So I'm able to run it
Is everybody able to run it? Getting your cars out. Now we can go to our console program.cs and add a read key to keep it open so we can see our output. Getting it? Yay! All right. So now we see what we're doing. We can handle this. We could do anything because we've got this list of car objects and we know we could load those to a list on our form or anything that we wanted to with them. So let's continue on looking at our data access layer, because now we need to think about being able to create new inventory within our database or update things, because so far we've just been trying to get to stuff. Let's see what else we can do. I guess before we can update a car though, we have to be able to find that exact specific car within our database. So let's create a method where we go find a specific car using a car ID, because that's going to be a really common thing for us. Let's add some. Oh, did you get it, Ivy? Up here, just go to your Solution Explorer and on your client project, right click and choose Set as Startup Project. See if that'll work. Let's make sure that does it.
Yep. I got it.
Awesome.
Thank you.
Thank you, guys. So I want to put some documentation here. This method is going to get all inventory rows from the table. So now we want to add a method that's just going to get one inventory row from the table, the one inventory row that we're concerned with. So we're going to make this a public method again, and it is going to be returning a car object because we want to get a car. So as we add our code here, we're going to be expecting to be passed a parameter of a car ID to go out and get, to make sure that we've got that car in the database. So the first thing we need to do is open our connection. We'll set up our car object. It's just an empty. Then we're going to set up our SQL string. We're going to use the $ thing to do as is. We want to select from inventory where car ID equals, and this is where the parameterized strings are so helpful, because we can say just replace this parameter with the ID. So think about your weird string program you had to do that. We could have to do a lot of string manipulation if we wanted to add that ID into this select string, but since we can do the $ with the parameter replacement, we don't have to worry about it. It takes care of it for us. So it really does make a big difference when we're working with SQL code. All right, so let's go ahead and do the same type thing. We're going to say using an SQL command object that we're going to create here, named command. We want to use this SQL code and our SQL connection. Within our using clause then, we're going to tell our command object that its command type is text again. Got two there. Like, wait, which one's the right one? All right, so we've got our text, and we're going to say that our SQL reader is going to be a data reader. Oop, that one always gets me because it's just a little different. We're going to say we want to run the command execute reader, and that we want to use the command behavior to close the connection. Now we can copy our code from up here. Let's grab it. Let's grab our while loop. So we've named our data reader the same thing. Notice that we haven't got an inventory list. So instead of saying that we're adding a new item to our inventory list within our while loop, we need to create a new instance of our car object. But we'll pass it the same parameters to create the car object, but I don't need the closing parenthesis since I am not adding that entry to the list using that list method. After our while loop is complete, we're going to close that connection, or our data reader, I should say, because our using clause is supposed to close everything. And Rich is making comments saying, close it anyways, close it. And that's very true, that we can leave pieces open all the time. Now, once we're done with our using clause, we can return that car object to our caller. And so now we've created a method that's going to go out to the database, get one particular car object. How come we still had to use a data reader? We only expect one. We know there's only one ID. We always have to expect results back as a collection from an SQL statement. So all of the SQL classes just assume that any results we get back could be a collection. So we'll always kind of have to loop through our results to see what we've got, even if we're only expecting one row. So let's see if we can test that method. Let's try to find a car here. They don't really have it tested, so we'll have to do it on our own. We can handle it. So looking at our tester, our program.cs, let's add something in. And we'll say one car. Setting car ID to 1. And then I'll copy our headings. And then we should be able to get that from our getCar method, passing in that car ID of 1. And then I'll copy our right line. And instead of item, of course, we're working with car now. Rich is trying to add a link query in. We're ignoring you, Rich. Okay, let's see what it does. So I've got all my cars, and then my one car, but if I do car ID 1, I got Zippy back, the black Volkswagen. So good, our method is working. How's everybody? Good stuff? Stuff? Good. Let's document that a little bit. Select one car by car ID and return the car object. So we have this method now set up where if somebody has car ID, they can get that specific car. But we're still pretty limited, right? Because it's not like we're letting them get all of the black cars or all of the red cars. We haven't built code yet to do that. So notice how this data access layer could just grow and grow with all of the different requirements we have. So we might see splitting it up, but actually it's good. It's all working. So let's try to add. I'd really like to add a car. So we're going to insert a new car because whenever we insert new rows in our table or add to our table, we use the insert statement. So to insert a new car, we're going to have to use the correct syntax for the SQL code to do that insert. So let's put this part. Oh, and a special thing about this, whenever we do an insert, we're not running a query. So we're going to use a special method, the execute non-query method. And that's the method we have to use to execute code that updates the database instead of selecting from the database. So when we don't expect any results to be returned, we're going to use the SQL non-query. So let's go in our data access layer. We want to create another method. And this one is going to be insert auto. Whenever we insert a car into our database, we're going to need to know some things about it. The color, the make, and the pet name. Remember, we don't need to know the car ID because the database is going to determine that itself. Oops, insert. I'm going to add some end of things here. We have a lot of stuff. Now, our insert auto, first of all, we're going to need an open connection to our database. And we need to have our SQL. So even though it's not going to be a select statement, we still have to do the same type thing. So we're going to insert into our inventory table. And what we want to insert are those columns, make, color, and pet name. So the values that we want to use for that can be found in our parameters. Now, this is where things can get really ugly because the syntax for the insert statement, since these are string values, they have to be enclosed within single quotes. You know how we can start getting into all those problems with escape sequences and stuff with C#. So again, this is why it's so great for us to be able to use the parameterized replacement. So I'm going to put the double quotes, or single quotes, I'm sorry, around the make, then a comma, then again single quotes around my color, and finally my pet name. Now I'm going to close the parenthesis for my values list. And then I should have the double quotes that close the complete string for our SQL statement. And then finally our semicolon. Now we want to execute that using our connection that we've already established. So we're going to use our SQL command called command. And we want it to process our SQL string using our SQL connection. Now, in our using clause, we're going to say that the command type is text again. And then we're going to execute it. Execute non-query. That's the end of our using statement, so we can close our connection. And then we should be good to go. Oops, what have I got there? Somehow I got an extra word in there. Okay, that looks good. We'd like to create another instance of this method that accepts a parameter of an existing car object instead of all these strings, because that would be cleaner for us, right? So let's do that. We'll have another one, insert auto. In this one, we're going to be using a car object. So we can pretty much copy everything, right? Copy. And right here, instead of specifying parameter values here, we're going to have to specify values from our car object. So our car object has those same variables, just in a little bit different name. So we have some code there that's pretty duplicated that we could probably figure out another way to do, but we'll take it that way. It works. If we have a car object to insert into the database, we'll use this method. If we don't, we just have string values, we'll use that method. I'm going to put a comment or two. This method inserts an inventory row from a car object. And then for this one, we'll say this method inserts an inventory row from string data. So you can see how as we develop this data access layer class, we're trying to make it flexible. I mean, that's our key here, is we want to have all of the developers that are using this be able to find the methods that they need. We don't want any developers out there saying, oh, there's nothing in my data access layer class that lets me do what I want to, so I'm just going to go access the database directly. Nobody will mind, right? Because I know how. Well, whenever we have all this layering going on, that's a big no-no, because now we've just kind of thrown a wrench in the whole thing. So let's try and insert one. I'm going to go to my tester, my program.cs file, and after we have our testing stuff that we've got so far, let's try our insert. And of course, we can't do this very often. We're going to end up with a whole bunch of the same car, but that's all right. So I'm going to insert my car, and let's say the first thing I want is whenever you're looking at your IntelliSense here, notice how it's showing you the first instance of this method of 2 instances, because it's an overloaded method. So I can go down to the second instance and see, oh, the first parameter I need is color. So I'll say it's a red. And then the next parameter I need is make, just in case we can't remember. We'll make it another Volkswagen. And its pet name is, how about Volkswagen? Okay. Now if I was really on top of things, I'll just copy this code and select that one car that we just inserted. What's the problem there? Do you see it? I don't know what its car ID is. Because when I insert, the database is going to assign the car ID, right? And I don't know what it is. So we're going to have to figure out some way to take care of that. And there's lots of different things we can do. And I want you to think about that's why we can't just display this car that we're going to insert. Everything's always got a few more steps than what we'd hope. Let's run it. It says it inserted it. So I'm going to have to go to SQL Server Management Studio to check. My inventory table. I can just open a new query. And now that I have my database open, I don't need that use statement. I can just select star from inventory. And there's my new red Volkswagen. It got car ID 8. If I ran this again, I would get car ID 9, 10, all with that same exact data, because we don't have any reason for it to not keep inserting. So we could keep doing that if we wanted to. Everybody's work okay? Got some data? Come on, where's problems? There ain't no way that you guys all are working. If you are, you're just the most awesomest group ever in the world. Which is coding more stuff. Okay, so awesome. We got stuff added to our database. One thing that I wanted to add, let me stop this thing from running. This would be a really good place for us to do a breakpoint. I'm going to set one up here at, I don't know, line 30, because I want you guys to see that insert statement when it's all done to really think about it. So I want to run with that breakpoint set, and I've gone past all of the other stuff. So I'm going to step into and go into our data access layer class. And as we start preparing to insert into our table, I want to look at that SQL string. We're going through and opening our connection. And now we're setting up our SQL string. So I'm going to go ahead and click next to execute one more, and then I'm going to look at that string. So here is our insert string, and we're just going to be starting on those in the database class, so it's kind of new syntax. But this is what's required. So see how we have to have those single quotes around those string values within that insert statement. So we can get pretty complicated in building these strings to get our SQL code properly set up. So it's always good to run the debugger and just kind of check it and make sure that it looks good. We know ours was okay because we got values inserted, but oftentimes that can be where the problem lies. You can have all of your C# code correct and just one little error in that string that you built for your SQL code, and it can cause you trouble. So we always want to, kind of take a look at that. Beautiful. Now in our insert auto, they say that this second method that we created is strongly typed. I'm going to put that in our comments. Because whenever we're accepting strings, we don't really have anything to do with that car type, that data type. It's just a bunch of strings. But in this instance of our insert auto method, we're actually asking for that car data type. So it is strongly associated with that car object, that class. That strong association. Okay, beautiful. Let's do some other things. What if we have cars that we would like to update? There's something wrong with them, or we would like to delete them. They've got the delete logic first, so let's add it. We're going to create our method. And we'll see that most of our database methods are going to be concerned with the car ID. That's our primary key. That's usually what we're going to be using to either select one car or delete one car or update one car, because we always want to make sure we have the correct one. So in our delete car syntax, again, we're going to open our connection. We're going to get the ID of the car to delete, then delete it. So first thing we want to do, they're going to go find it, I guess. No, they're not. Some people would. Some people would actually do a select to make sure that it was in the database before they tried to delete it. But we're going to delete from our inventory table where our car ID equals the ID that we were passed. So pretty simple syntax. Looks a lot like a select statement, right? We say, instead of saying select, we say delete. Other than that, everything's pretty similar. So now that we've got that select statement or delete statement set up in our SQL string, let's start our using So we're going to be using our connection and our command. And in this one, we're going to be good and put in our try. Good example for you. Now in our command, we're going to set up our type again is a text. And then we're going to say to execute that non-query command. Why I keep getting that one. Probably because I'm picking the wrong one. All right. Execute it. Now, if we have an error, we'll catch our SQL exception as an exception object named EX. And here we go. Good code for us. We're going to throw our own exception and say, sorry, that car is on order. Assuming that we can't delete it because it wasn't found. So this exception is just assuming that the error we're going to get is that the car didn't exist in the table. So we're going to say, oh, we must not have it yet. Throw our own exception instead of letting the system exception occur so that we can control it. So there's the end of our catch, end of our using, end of our method. And after our using, we want to close our connection. We have that nice method. Let's use it. So now I should be able to delete my car. Let's try it. I'm going to add it to my tester. I'll copy the code we put in for inserting a car. And I'll say I'm deleting a car. And I'll set my car ID to 8 so I don't delete one of those ones they wanted us to have. And then we'll do our delete car method using car ID 8. And again, I'm just going to run it. I should have a new Volkswagen that's car ID 9. I'll run this command again and see. Yep, my car ID 8 is gone because I deleted it, but I do have a new red Volkswagen in car ID 9 because I did also keep my insert code in there. Is everybody able to delete? Real world, that's so nice. Very, very good. So the last thing we need in our data access layer class then is an update. So we're in really, really good shape. So let's add that method. We have just about enough time. So in our update, we're going to call this update car pet name because we could have a bunch of different update methods again, depending on what kinds of things we thought people needed to be able to update. We could also set up an update method that just took in every field and updated all of them. People do that a lot, where you'll have to just send in the whole car object or whatever to get it all updated. So we could do either way. But in our example, we're only going to expect a parameter of the car ID so that we know which car to update and the new pet name so that we can update its pet name. Oops, I'm still running. So in my update, we're going to do a lot similar to what we've done before. Get the ID of car to modify. So we're going to set up our SQL string using update syntax. So we want to update our inventory table. We want to set our pet name equal to our new pet name variable. So we need single quotes around it, where the car ID is equal to our ID. Now, in the textbook, they have single quotes around the ID. We'll try it. All right, we're going to set up our using statement then. Using our SQL command called command. We want to process our SQL code using our SQL connection. So in our using clause, we're going to execute that command. Execute non-query. And then after our using, we're going to close our connection. Rich, I think it's going to, Aaron, yours didn't delete. Okay, we'll fix it. Yes, Rich, I think it's going to throw an error. We'll see. Let's put in our test code. I'm going to comment out these ones momentarily. Don't do that very often. And I want to add in an update. Update car pet name. And I think that I'll do car 9 that I know I inserted recently, because I just say that pet name, you know, Volkswagen. That's not a very good name. So let's make it Ruby. Be a better pet name. Now I'm going to check real fast my database, run that select statement. See car ID 9. I should be able to update that. That looks good. So I'm ready to try it. It says it's updating the car. So I'll close this and rerun my query. And it's still Volkswagen. We didn't get any sort of error either. So you notice that. So I'm going to set up a breakpoint right here on this statement where I'm building this SQL code. If you notice, I'm kind of questioning their code. So I'm going to check and see what it looks like when it's all built. And the reason we don't get an error is, you know, if it executes the SQL code, but the SQL code doesn't do anything, it ran fine. It just didn't do anything. So we don't get any sort of error. We don't know anything. So let's run it and see what we got. Used an ID that's in the table, yeah. Now, when we look at our update, we see it. We're saying update inventory, set the pet name equal to Ruby, where the car ID equals 9. Does anybody notice anything wrong with that? Having to do with data types? Do we need the single quote around something that's numeric? Are we doing our SQL wrong here? You don't know because we haven't got to update statements, but think about just normal programming rules. We probably shouldn't have the quote around the numeric data. Whenever we did our select statement using a car ID, we don't have a single quote around the ID because it was numeric. So let's try it. Okay, I got my message that it's updating it. Now I'm going to go check. Oh, it still says Volkswagen.
You didn't open, I think.
Do I?
I think you need to open the connection first, right?
Where are we?
In update car pet name.
Yeah, we didn't open a connection. That could be a problem. What else? Does that do it? Let's see. We didn't get an error about that either, did we? Oh, wow, yay. So notice how all of these different things can cause us trouble. I'm going to put the single quotes back on there to see if that mattered. And I'm going to change my name again. We'll name it Ruth. See if it cares. Sometimes it can be so forgiving and sometimes it's so mean. So it didn't care. So it was our connection issue all along. I thought it was those double quotes or the single quotes. So good job. This is a super good example of why it can be so helpful to have other people's eyes on your code to see what's going on. We did it. We did it. You guys did it. You wrote a whole CRUD application. Maybe it's console based, so it's kind of cruddy, but it's a whole CRUD application in one class sitting, just did it. So you have code now. This data access layer can be our back end. We can replace our front end project and not have a console based project. We could use, you know, a list type application, could do that kind of application that you did for your final in C#1 where you had the list and, you know, a toolbar where people could add, change, delete. And now you're adding and changing and deleting to the database instead of just within those arrays and classes within your code. So you're using persistent data that's so much more meaningful. So you can see how it takes a while for us to get to that level. There's so many layers of knowledge that you guys have to get to this point. So one thing to just copy code, but another thing to actually kind of have an idea of an understanding of what you're doing. Yeah, let's see your delete. Here's the delete. Now go through and put some commenting in because I did not comment well those last couple of update methods in our data access layer. Aaron, do you see it? Okay, great. Is everybody's working okay? This is a lot like we're going to need for our employee application that we're working towards on our own. Rich, I don't think so. We'd have to do a, unless we did a hokey way, we could select based on some of the other data that was given to us to get the car ID. I've seen that, but yeah, kind of hokey. So we would probably want a stored procedure. Next time, that's what we'll look at. We created that stored procedure in our database. So we're gonna add code to actually run that thing so that we can see how that works. You want stored procedures like that so that we can get away from this problem of SQL injection. We see how our SQL commands are just built on strings. That's kind of a basis of SQL injection, which is a hacking technique where people find a text box where they can enter like an ID that's going to be used in an SQL command, and that'll actually put
an entire SQL command in there instead, like select star from users of this database to try to figure out what the admin password is and things like that to be able to get in and hack. So when we're using stored procedures, we don't have that opportunity to have SQL injection occur and that hacking kind of stuff. So that's what we'll look at next time. But great progress on the database piece. Lots and lots of pieces going on here. So yell if you're having any trouble, anything isn't working, so we can get it fixed. Get out of here. Have a great weekend. Unless you're having trouble. You guys have a great weekend.